Dangal greetings, Sir Janus. I am Emmanuel Abaya, the group leader for CCS102 Group 5. Along with my members, Castor Harold Vincent, Ejeda Arian Faith, Elago Hayden James, Magbanua Nel Dustin, Manjac Giancarlo M, Mariscotes Anday Michel P, Perey Andre James, Prado Madeleine, and Vargas John. Now we would like to discuss to you the details and the processes of our research project.
Good day everyone! Today I will be presenting our Java grading system. This program is designed to compute a student grades for the prelim, midterm, or final term by calculating the lecture and laboratory components based on their assigned grading percentages.
So, let me introduce you to the program. Yung program na nabuo ng group is Grading Calculator System. So, dito, ang layunin nito is para mapadali yung final grade computation mo ng prelim, midterm, and final. So, ngayon, pupunta naman tayo sa problem statement. Meron itong 3 parts, which is the requirements, input, and process. So, sa requirements is kinakailangan i-accept ng program yung student's information, like yung student's name and student number. Then, after nun is kailangan mapakita ng program yung term choice, which is prelim, midterm, and final. Then, after that, dito na mangyari yung input, which is i-input mo yung scores mo, scores ng mga activities, lab exam, mga quizzes, etc. etc. Then, after that is paano nga ba mako-compute yon? So, yung final grade mo is like each component kasi may percentage yan. So, each component is meron siyang designated na percentage, which is, for example, sa laboratory exam, meron tayong 60%, while sa laboratory activity is merong 40%. So, yung for 60% and 40% is ipagsasama yan kasama nung lab grade is para mabuo yung total na final grade. Then, after that is doon na i-display ng program yung information and then yung term choice mo and then yung final computed grade mo. So, yung program nito is for efficiency, is para hindi ka na mahirapan mag-compute ng grade mo, is i-input mo lang yan through the display, and yeah, that's it.
Good day everyone. I will be explaining the algorithm of our CCS102 grading system. The algorithm is the step-by-step process that our program follows to compute a student grade. It starts by asking the user to enter their name, student number, and the term they want to compute, whether it's prelim, midterm, or final. Next, it collects the lecture grades, including the class participation, quiz average, other requirements, and written exam. Each score is multiplied by its corresponding percentage to get the lecture total. After that, the algorithm asks for the laboratory activity and laboratory exam grades. These are also multiplied by their assigned percentage to compute the laboratory total. Lastly, the lecture total and laboratory total are combined to calculate the final term grade. The program then displays the student's information, selected term, and final computed grade. That is how our algorithm works. Thank you.
Good day. Today we will be discussing the construction of our pseudocode. But first, let's discuss what is pseudocode. Pseudocode is the blueprint or draft of a computer program. It is a human-readable language with a combination of detailed coding language. So, the pseudocode program language that we have used are input, read, and output. So, what is input? It means that the user will be inputting something in that specific variable. Then the read language, it means that the input will be read into that variable. And lastly, output is simply displaying the output on the screen.
Okay? The program starts with the start statement, which indicates the beginning of the program. Next, the program prompts the user to enter the student's name and student number. The input is then stored in the variable called student dates. This variable is used to identify the student whose grade is being computed. After that, the program asks the user to select which term they want to compute. The choices are 1 for prelim, 2 for midterm, and 3 for finals. The selected value is stored in the variable name called term choice, which will later be used to determine the name of grading period. The program then proceeds to gather the lecture grade components. It first asks the user to enter the class participation score, and the value is stored in the variable name called class part. Next, it asks for students' cumulative quiz average, which is stored in the variable name called quizav. The program then prompts for the total score of the other requirements, such as attendance, bonuses, and other class requirements. This value is stored in the variable name called other recs. Finally, it asks for the written exam average, which is stored in the variable name called written exam. Once all the lecture components have been entered, the program computes the weighted contribution of each component. The class participation score is multiplied by 10% because it contributes 10% of the lecture grade. The quiz average is multiplied by 20%. The other requirements score is also multiplied by 20%. Lastly, the written exam average is multiplied by 50% since it has the highest contribution to the lecture grade. After that, applying the corresponding weights, the program adds all the weighted score together. The result is stored in the variable lec total, which represents the student's total lecture grade before it's combined with the laboratory grade later in the program.
Thank you, James, for explaining the lecture part of the pseudocode. Moving on, let's tackle the laboratory part of the pseudocode. First, the user will be asked by two inputs, the laboratory activity average and the laboratory exam average. The laboratory activity will be multiplied by 60% and the lab exam will be multiplied by 40%. Then the laboratory total will be the sum of laboratory activity plus the laboratory exam. Then the lecture total will be multiplied to 60% and the lab total will be multiplied to 40%, and that will be the totality as 100%. Then the end of the term or the term total is the sum of the lecture total plus the laboratory total. Next, this part, the user will be asked if they want to know their grades in prelim term, midterm, or final term. Then the output student or in the variable student dates will be printed out using the system out print. Then the grade will also be displayed on the screen under the variable term name plus term total. And that's the end of the pseudocode.
Dangal greetings. My name is Madeline Prado. This flowchart shows the algorithm for a grades program that computes a student term grade. We have four shapes that we use. First, oval. Ito po yung start and end. It marks the beginning and ends of the process. Clearly shows where the flow begins and stops. And second, parallelogram, input and output. This entering the data represents data entering the system or information being shown to the user. Rectangular process, the calculation, assigning values, action, formulas, or steps where data is changed or computed. And fourth, diamond decision or decision. Um, a term choice. It represents a yes or no or multiple choice condition that change the flow direction. And last, we have arrow. It's connecting all steps. It shows the sequence and direction of the process.
I am Nel Dustin Magbanua. So this is the first step of the flowchart, the input, basic info. First, the program asks the student's name and student number, storing it in student deets. Then it's asked which term to compute. First for prelim, second midterm, and third the finals. And it is stored on the term choice. And the second step, lecture grade inputs. Next in collects for score, class participation, cumulative quiz average, and other requirements, and written exam average. And step 3, the weighting the lecture components. Each score gets multiplied by its weight. Participation 10%, quizzes 20%, and other requirements 20%, and the written exam 50%. Adding this gives lecture total. So moving on to step 4, the lab grade inputs. Where's the lab grade? Here's the lab grade. Then he asked for 2 more scores, laboratory activity average and the laboratory exam average. And after the laboratory exam average, we go to the step 5, the weighting the lab components. Lab activities weighted for 60% and 40%. Together, they form lab total, lab total of 100%. And here's the term choice. Step 7, this is the term choice na. Now the program check the term choice if it's 1 term name, is prelim term, or it's 2, the midterm, or otherwise the final term. And the last step, the 8, the output. Finally, the program will display the student's detail, the term's name, and the term total. Then the program ends. And that's it for the flowchart. Thanks for listening with us, with Miss Prado and me, Mr. Magbanua. That's all.
Hi everyone. For our code features section, we are going to break down how we translated our grading metrics into a functional, user-friendly Java program. Instead of treating the program as a single massive block of code, we designed it with specific structural features to ensure smooth execution, accurate computations, and clear user interactions. Let's walk through the core components that make our CCS102 grading system work. The first thing we did was utilize the scanner class to allow real-time data input directly from the user. This transforms our program from a static script into an interactive tool. It prompts the user dynamically for text like the student's name and number, and numerical values like quiz averages and exam scores without needing hard-coded variables. We also incorporated clear visual separators like this one, using systemout println and custom text dividers like these dashes. A clean console interface is crucial for user experience. The next thing we did was inline percentage weighting and arithmetic accumulation. Rather than creating multiple redundant variables for weighted grades, we directly multiply each input by its respective syllabus weight. Like for example, the class participation at 10%, quiz average at 20%, and written exams at 50%. and accumulate them into subtotals like the lab total and the lab total. This keeps our memory footprint low, keeps the code concise, and directly mirrors the exact mathematical formula prescribed in our course orientation guidelines. For the conditional evaluation for term naming, we use a nested ternary operator, this one. Instead of writing bulky if-else blocks just to print the correct term name in our final summary, this compact line cleanly evaluates the user's numeric choice, if it's 1, 2, or 3, and assigns the corresponding string label instantly. For our final score display, we implemented systemout.printf with the format specifier %.2f. Floating point arithmetic in Java can often result in long decimal chains. This feature ensures that the final grade is cleanly rounded and presented to exactly 2 decimal places, matching the standard academic grading formats. And those are the primary code features driving our system.
So here is a test run of our grade system program. First, you must put your name and your student ID number. Then, you must select which term you want your grades to compute to. So I will choose the prelim because it is currently in the prelim period. Then you must enter the class score. All the scores ranges from 0 to 100. So I will put all my scores in here. And there you have it. It will display your student name and student ID number along with your average grade for the whole term.
I am Andre Michel P. Mariscotes, and that concludes our presentation of Grading Computation Program. To recap, our program takes in a student's name, student's number, along with the scores for class participation, quizzes, other requirements, and written exams. Then computes the weighted lecture grade. It does the same for laboratory activity and lab exam scores to get the lab grade. And finally, combines both 60% lecture and 40% laboratory to compute the final term total, whether it's for prelim, midterm, or finals. This project allows us to apply the key programming concepts such as variable declarations, arithmetic operations, weighted computation, and conditional statements to determine the correct term name based on our user input. Thank you for watching our presentation. We hope this gave you a clear understanding of how our grading system works, from data input all the way to the final computed grade. We're now open to any question you may have.